Okay, so inverse variation in graphs. There's actually, if we've got time at the end, there's actually two other types of variations that we talk about, but the big one that we've got to worry about is inverse variation for that part. And with inverse variation, here's the big thing. As one variable increases, another variable decreases. Okay, and as they're doing these with variation, the key thing on this is as they're increasing or decreasing, whichever way they're going to go, it has to be at a constant rate. And with these two parts that we're looking at, no seniors in here, but when you get to be seniors, you'll talk about supply and demand with economics. This is one of the big things that in economics that you're trying to find that happy medium of finding out where you can kind of get these two things together for this part. So we think about inverse variation. What if I told you fill in the blank? Your favorite artist is giving a concert, and tickets are $1,000 a piece. How many people are going to go? Got one. Okay, so $1,000 ticket price. We got one person going, so we're here. What if I told you ticket prices were $1 each? How many are going to go?
All of us.
Everybody, right? So that's the ticket prices is that inverse variation. That if you put the ticket prices really high, a lot of people go, I'm good. You put ticket prices really low, everybody says, I'm in, right? Think about gas prices. Same way, right? The higher the gas prices get, how much do you want to travel? Not as much, right? You don't have as much money to spend, so then you got to start going, all right, I got to balance this thing out a little bit for this part of it. And with inverse variation, when you start talking about economics, it's finding that balance of getting the right price on things so that everything kind of, you don't have this huge stockpile of stuff and you're not stuck with that. Same thing, let's say the new, with an iPhone person, let's say the new iPhone 16 is coming out, or if you're a Samsung person, the next Samsung phone's coming out. And they're $10,000 a piece. Everybody's going to wait, right, for the most part?
Right.
Yeah. But again, they got to find a happy medium of, okay, even though it's $1,000 for the new phone, we're going to give you a discount. It's only going to be $25 a month. Everybody goes, all right, I can handle $25 a month, to get the new phone. So inverse variation is that thing if you've got one going up and one going down, and you're trying to find that happy medium where you balance things out on this thing. And for all these things that we're doing, question.
You know how when gas prices went up to like $4, I think that's paid rate.
Yeah.
I know people started buying like the gasoline, containers. You know what I'm talking about?
Mm-hmm.
Aren't those like this video has a lot
Okay.
of squirrels in it.
All right. So for this one, as we're going through these with a constant rate, when you do, because we're talking about the two variables, things we're working with here. So we've got X and Y. So as we move through the X and the Y, that when we're doing these, that they can be basically going to be the same for this. So when you've got X and Y, when you do X times Y for all your order pairs we're looking at, because again, we're going to graph these, the X times Y value basically must be the same. So if you give me an X value, we can figure out what the Y value is. And when you do this X times Y, that's going to equal, they're going to call that K. And K is what they call the constant. Why they wouldn't call it C, I don't know, but they don't. Yeah, none of those English things that don't make sense. K should seem like it should be C, but it's not. It's K. K is what they call the constant of variation. That as you vary this thing, there's always one thing that's going to be the same, as we're going through and working with some things here. Yes.
Oh. That says order.
Yeah, order pairs.
I'm not like it. That looks like a B.
All right. There we go. Ordered pairs. Yeah, it's not the very best in the world there. So. Okay, and the one equation we're going to use for anything inverse variation, and again, this is only using two variables as we go through this thing, is y equals k over x. If we bring in a third variable, it changes things up a little bit, but for this one, we're basically going to compare two variables as we're moving through this part, and just figuring out, what we're going to get for this thing. All right, so one of the first things we're going to do is we're going to find the k value. And then we're going to write an equation.
I don't have any.
Okay, so here's basically what we're looking at. So this is the generic equation. If you've got just a basic generic equation that somebody's going to ask you to work with, that's the part we're going to do. And what you always have to find for this equation is you've got to figure out what the k value is. And again, this is kind of going back to the part back here that these things are going to vary. If one price goes up and one price goes down, they're always going to balance each other out so that if you multiply the two things together, it would be the same. So again, to find the constant or the k value, you just got to multiply x and y. Okay, so a couple of things we're going to do is some of these, and we'll show you, this is a part where they're going to tell you in a second that this one, they will tell you this is an inverse variation. They're going to tell you that part of it. Now they're going to ask you to find the k value, which again means to find the k value, you just got to multiply x times y. That every time you do x times y, you've got 1 times 12 for 12. You've got 2 times 6 for 12. 3 times 4 is 12. 4 times 3 is not 13, but 12. So no matter what you do for every ordered pair you have, they're always going to multiply together for this thing. So since those are all the same, that means your k value would have to be 12. All right. So your equation that they're going to ask you for, they may ask you to write just a generic or a basic equation or a general equation. Basically just means you got to plug in the k value. So that would be y equals 12 over x. So there's our k value. There's our general equation, our basic equation, our standard equation, whatever equation they want to call it there. That's the numbers that we're kind of looking for. All right, so there's your basics on inverse variation. That's just the parts of it that's there. And go ahead and show you the next one. So the other type of variation we're going to do, now this part, I'm just going to show you this one because there may be some of these parts where we're going to ask you, is this an inverse variation or direct variation for this part? But again, just kind of think that everything we're doing is we're trying to find inverse variations because what we're doing. Direct variations will show you what they are, but everything we're going to do is really going to key on inverse variation. So just kind of, we're not going to do a whole lot with direct. We're going to just show you what one is, but everything today we're going to key on inverse variation with it. Okay, so there's inverse variation. Direct variation basically would be this.
My dog, this is my dog. We're outside.
Okay, so direct variation is, again, basically the opposite of inverse variation. Sometimes they call it indirect variation, so inverse. So direct variation basically this is one variable increases or if a variable decreases, we'll say the other variable does the same. So it doesn't matter what the first variable does. If the first variable increases, the second variable is going to increase. If the first variable decreases, the second variable does the exact same thing. Y'all doing direct equation in chemistry? Okay. Okay. Your basic, and again, the K value is still the same, but we'll get to that one a little bit different. Your direct variation equation is basically this. It's y equals K times X. That the X value is, and why it's direct is the direct is right beside the K value. When we do inverse, it's upside down kind of thing. So the X value is below or divided by the K value there. So if it's direct, it's directly beside the K value. If it's inverse, it's underneath the K value. If you want to kind of think about it that way. All right, so that's our equation. If you have to find the K value, to find your constant in this case, well, if that's our equation we have, we would divide both sides by X. So for this one, the K value would be Y divided by X. Okay, so the equation is Y equals KX. The constant would be K equals Y over X. And this is one of those things that y'all have done this for so long, just nobody ever called it this. Does anybody know what the formula is for area of a circle? The one that everybody knows. R squared, right? That is a direct variation equation. Because your K value, your constant, if you do a square, in this case, your pi value, which is 3.14, that is your K value. That's the one thing that's the same no matter what you do for any circle, anywhere, no matter what you're going to do with it, K value is always 3.14. What happens if you increase the area in a circle? What happens to, or the radius? What happens to the area?
Oh, so yeah. I'm lost.
Okay, so what we're going to do is you may have some of these where you got to figure out whether something is direct, inverse, or neither, because sometimes it may be that it's, if you've got two variables, there may be a third variable that's involved with it so that you may not quite understand. Or again, the two variables just may not be interrelated. There may be no correlation on that. So we're going to give you table values. They're going to ask you, is this thing direct? Is it inverse? Or if it's neither one of those two, then it's going to be just neither at that point. Okay, so going back to the last one. For inverse variation, we took two things, we multiplied it together. And I always tell people, start with that one first. Start with something to multiply them together to see what happens if you do X times Y and see if you get the same number every single time. If you do, you know that this K value is 12. And again, that's going to let us know that we're talking about something that's inverse. If we've got a set of numbers that's here and maybe it doesn't multiply out, then we've got something other than inverse for this thing. So let's do this one. So let's say that we've got table of values this time. Let's go X and Y. Let's go with, I know y'all love decimals. Let's go with X is 0.2 and Y is 8. X is 0.5 and Y is 20. Let's go 1 and 40. 1.5 and 60. It's an example I used before. So, yeah. Okay, so when you get these, always try doing x times y first, and just because that's always easier because multiplication is a lot easier. And that one, the page, it should jump off at you on the page. If you do x times y, you've got 1 times 40 over here would be 40. You've got 0.5 times 20. Half of 20 is 10. So you know that these aren't going to, and again, if you do this one, this is like 1.6. So you know that x times y is not going to work. Okay, if x times y doesn't work, then we're going to try direct variation. So that would have been inverse. So now we're going to do, for the, see if the k value works, if we do y divided by x, see if we get the same thing. Okay, again, we'll get the easy one first to make sure we got it, because we've got 40 divided by 1, that's 40. Okay, so that's no problem. What happens if we take 20 and divide it by 0.5? Move the decimal over, right? Make that 5, make that 200. 5 will go into 200 40 times. If we take 8 and divide it by 0.2, same thing. We're going to move that decimal place over to make it a whole number. We move this over to make it 80. 80 divided by 2 is 40. So then if we take 60 divided by 1.5, work through the decimal numbers, move it out. Anyway, again, we still get that's going to be 40. More than likely, y'all would check that with a calculator, right? Not do it by hand. So anyway, we get the same value this time by dividing. So in this case, we do get a k value that's equal to 40. And since we had to divide the two numbers, that means this thing was direct. Oh, the red numbers were if we did x times y. This was trying to find inverse. So inverse, you would do x times y. For direct, you would divide y by x.
We're done, right?
Okay. Well, with this part, yes. All right. Now, if you did both of those, if you did multiplication and it didn't work, if you did division and it didn't work, then if neither one of those two work, then obviously they ask you, are they related? You say no, they're not. There's not a relationship that's either direct or inverse. It's something else that would be at that point. All right. Now, here's the big thing we're kind of moving for today. That as we're going through these, and again, that's just a second option we've got. There's actually a third option that, in a minute, I'll just tell you about that one. We're probably not going to take notes on it, but there's one third option that we'll worry about. But the one thing we're going to do for this one, and again, this is going to go more back to not direct variation. This is kind of a spin off of inverse variation. Is that's going to tie us into the next thing that we're going to come up with. And I think we talked about this just a little bit way back when. We're going to kind of bring it back in again for this part. Did we talk about asymptotes? No? Okay. Couldn't remember if we did. Anyway, so that's the next thing we're kind of moving to for this part. It's a very funny sounding word, but there's your asymptote. All right, and basically this, an asymptote is a line that a graph gets close to. But never touches. Okay, and you can almost think about, it's not quite like this, but you can almost think about an asymptote like infinity. Can you ever get to infinity? No, you can keep moving in that general direction, but you never quite get there. And so with these, it's basically there's two different types of asymptotes. You have a vertical asymptote, which for short we'll just call it VA because that's a lot easier than saying vertical asymptote. That's a basically when we start looking at these things, because if we're going back to inverse variation on this thing, and again we're kind of keeping this thing in mind that we're working with inverse variations, that when we talk about those in this case, a vertical asymptote is where the denominator is going to equal 0. Okay, and for your horizontal asymptote, which we'll call HA for short, these are going to occur when you add a number outside the fraction. Now, we say add could also be subtract, so it could be a negative number as well. So either add or subtract the number outside the part space. And the basic general equations for vertical asymptotes, it's always going to be x equals some number. And for a horizontal asymptote, think about when we did lines of symmetry. If we did a vertical, we didn't do a vertical asymptote. We did a vertical. What is the word now? What did we do when we did the vertical line? Line of symmetry. There we go. Thank you. When we did the line of symmetry, it was always a vertical line. It was always x equals the x value of the vertex. So vertical asymptotes can be the same thing because it's a vertical line. It's always going to be x equals. Horizontal is going to be the opposite. It's always going to be y equals some number that we're looking at. Okay, so we're going to give you a number that's fairly easy to work with here. And we're going to graph this thing so you can see where the vertical asymptotes and where the horizontal asymptotes of this thing will be, and exactly kind of what an asymptote is if we look at it. And for those of you get ready going into pre-cal, this is something they'll kind of work on a little bit more as you get there. All right, everybody good there before we move on? Hold that right there. Okay. Okay. So what we're going to do now, we won't do this on every single problem, just doing this one time so you can kind of see what it is. And then after this, we'll give you just a quick graph on these. Is that if you had to make a table if you have to graph this thing, we're going to make a table of values. So we've got some value for x. We're going to plug it back in and figure out what the y value would be. And I'm picking 4, so we've got numbers that are fairly easy to work with. So if we plug in 1 for x, what is 4 divided by 1? That's easy, right? That's 4, okay? If x is 2, 4 divided by 2 is 2. We're going to skip 3 because it's a decimal number. No need to worry about it. If we go to 4, 4 divided by 4 is 4. Okay, no big deal there. Now, we're not going to worry about 5 because, again, decimal number. We are going to give you one decimal number, though. What if? Oh, sorry, 4-1. Oh, bad. Thank you. 4-1. Yeah, I got the weight there. I was like, wait, what did I do? Okay. All right, if it's 8, what's 4 divided by 8? Or in the real world, 4 divided by 8 is a half, right? Somebody else said 2. Remember, got to go 4 divided by 8. So fraction-wise would be a half. Let's just think that'd be 0.5, right? All right, now, if we had the same numbers, same exact numbers that make them negative, what happens to the numbers? Instead of positive 1, if we make it negative 1, what's 4 divided by negative 1? Yeah, the answer's just going to be negative, right? So if we have the same numbers for x but made them negative, it's just going to take the same answer we've got and make it negative. Put the correct number now. Negative 1, not negative 4. We make that negative 8. That would make that negative 0.5 or negative 1. Okay, now here's where the part comes in. What if I plug in 0? What is 4 divided by 0? There we go. Thank you. So 4 divided by 0, that would be undefined, not possible, anything like that. And this would be the day that the drawer is stuck and I can't. So anyway, so that would be not possible. It's undefined. And that's what we're looking for, that at x equals 0, we're not going to get an answer. So that's where they're saying this thing has got an asymptote that's going to be here. So if we were to graph these points so you could see it. We'll do the graph over here on the side. Okay, so there's our graph we got. Again, I'm gonna put these so we're going 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we'll go 8 in every direction because now we can stretch that even farther, but 8 is plenty far enough to get this thing stretched out so we can see what we need it to be. Okay, if you start to plot all these points, we've got 1, 4 would put us up here. We've got 2, 2 would put us here. We've got 4, 1 would put us here. We've got 8 with 0.5 that would kind of put us there. Okay, it's hard to see because that's going to be really close to line, but if you start connecting these dots, you get a graph that will look something like that. Okay. And if we do everything negative, it's just going to be the opposite. We got -1, -4 would put us here. -2, -2 would put us there. -4, -1 would put us there. -8, -0.5 would put us there. And again, if you start to connect those dots together, it's going to start to do something like that. Okay, and so here's what we've got. If we do this thing, that if we start to graph this one, these numbers are going to keep getting smaller and smaller and smaller. They're going to keep getting closer and closer to 0. But again, we never get there because if you actually get to 0, it's undefined. So that's where we're going to have basically, it's almost like a fence that's here. That there's basically like a fence that's here that you can get. Everybody knows what electric fence is? You know, the fence, you get up to it and you put your hands on it, it'll shock you. You can think about that being an electric fence that's there. You know, like Jurassic Park, you got a fence that keeps the people away from the, you know, from the T-Rex. That you've got a fence that's here that kind of keeps them out. Same thing here. You've got a fence that would go this way. That would kind of keep everything separated that way. So that's you know, and that's our asymptotes. There's a vertical asymptote at x equals 0. We've got a horizontal asymptote also at y equals 0. Okay, now, are you going to have to do that every single time with this table of values? Absolutely not. That just like when we did quadratics, we're going to show you a shortcut on how to get this graph really quick without having to plot 10 or 15 or 20 different points or whatever you're going to do for this thing. Oh, now one other thing we'll throw in this one. If they happen to ask you about domain and range in this case, because we haven't talked about domain and range a little bit, basically you can say that your domain and range would be all real numbers, except for you're going to skip over x equals 0 because that's where we've got this line, this fence that's here that says, all right, you cannot touch that one. It's going to shock you, you know, that kind of thing. So it's all real numbers except for x cannot equal 0. And same thing down here for your range. It's all real numbers except for y cannot equal 0. Because again, that's kind of this point that's here. Okay, so that's the long setup. Here's the short setup that we're going to do. So we're going to give you a problem. You're not going to have to plug in all these different points. That we're just going to have this quick, easy little thing that we can do. And you can graph it just based on kind of just a couple of parts that we're going to look for. Okay, so here's what we're going to do. Here's the shortcut we're going to do for these. Again, instead of having to plot, 45,000 different points, basically here's what it comes down to. Okay, so we're doing transformations of inverse graphs. And again, we're starting with y equals k over x. But now we're going to have it where we can start adding, because now here's the thing. If this top number had been 8 instead of 4, the graph looks exactly the same. If this graph top number had been 40 instead of 4, the graph looks exactly the same. If this graph had been 14 over x, the graph looks exactly the same. So what the top number is, now the only thing that's going to change on it is how steep this will be and how fast this will curve. The bigger the number, the faster it turns. The smaller the number, the more gentle the curve is. But it's still going to have that same basic shape on this one. So with transformations, basically it comes down to this. How we found h and k with the vertex when we did quadratics, this one's going to be basically the same thing. That the h that's down here in the denominator, this is going to be h units in the opposite horizontal direction. And then the k value, well, that's your vertical movement. So just like when we did quadratics way back when, the number on the inside of the parentheses told us how much to go left and right in the opposite direction. The number on the outside of the parentheses told us how much to move up and down. The only thing that's different with this one is with the inverse graphs, now it's the denominator. Whatever number you have in the denominator is how much you're going to move in the opposite horizontal direction. Whatever number you have that's outside of the denominator, that's going to be your vertical direction. So all we're going to do is we're going to take this graph that looks like this, and we're going to move it up or left or right or down, and then we're just going to move this thing around as we go through the parts of this one. Okay, so here's what we're going to do. We're going to graph y equals, it can be 1, doesn't matter what the top number is again, really, over x minus 3 plus 2. Let's make it 7. So 7 over x minus 3 plus 2. So we're going to graph it. We're going to name the horizontal asymptote, the vertical asymptote, and the domain and range. Okay, and when you do these two things, that's going to basically tell you what your graph is going to be for this part. All right, so for the horizontal asymptote, name. Yeah, NAME. Yeah, sorry, getting too big a hurry. Got to slow down a little bit. All right, so for the horizontal asymptote, that is just your denominator equal to 0. So that's x minus 3 equal to 0. If we solve that, we get x equals 3. Again, if they ask you to talk about the direction you would move this thing, you would say this would go 3 spaces to the, not to the left, but you go opposite way you normally think, you're going to go 3 spaces to the right. The 2 that's here, that's 2 up. So this number is your horizontal asymptote. This number is your vertical asymptote. I mean, wait, hang on. I got those backwards. Hold on. I'm doing backwards. That's the vertical asymptote. Sorry. As soon as I wrote that second one down, I was like, that's not right. All right, so there we go. So vertical asymptote is x equals 3. Horizontal asymptote is y equals 2. So this number, because it's always got the x with it, that tells you it's the x value. That's your vertical asymptote. This one doesn't have a value. And this one, basically, we're just assuming that this part would be gone. That if this part was gone and we actually got rid of it, because, again, if we plugged in 3 of the undefined, if this part of the thing was gone, we would then move it 2 spaces up. So that's the y value you've got here that would match up with that part. So x value comes with the x value. If you cover that up, now you've only got the y value left, so that's where we got the y equals 2. Okay, and when you graph this thing, again, you're not going to have to plot 40,000 different points. All you're going to do is you're going to move 3 spaces to the right and 2 spaces up, and that's where the center of the graph is going to be. So we're going to go 1, 2, 3, 1, 2. So now our new center of our, instead of being centered at 0, 0, now we're going to center it here. And our vertical asymptote is going to go here. And our horizontal asymptote is going to go there. Good. And the only thing you have to do for the graph, put it here and here. So again, we're still going to take the same two lines we had here, but now we just moved them 3 spaces over, 2 spaces up. So it's those same lines that's there, but now they're just going to be here. Probably should have done those in red, make them stand out, but that's okay. Okay, and then for domain and range, it's all real numbers. Again, you just tell me it's everything except for your vertical asymptote, so x cannot equal 3. And then for your range, it's all real numbers except for the y value at 2, but y cannot equal 2. There we go. Okay. Now, and if the numbers, so basically on this part, if the a value is positive, this top number is positive, you're going to go here and here. If we had changed the a value in this case to be negative, to show you that, everybody good there? I'll show you that one real quick. So when a is positive, your graph is going to be here and here. And if a is negative, it's going to be in the other 2 corners. Instead of being here and here, it's going to be here and there. Okay. And every graph will look exactly one of those 2 things. It's either going to be a graph that looks like that or a graph that looks like that. So if we had taken this answer back here, so if we'd taken this same graph we'd had back here and had made this a negative up here, then we put the graphs here and then here. So positive numbers, it'll be here and here. Negative numbers, it would be here and then there. And every one of the graphs, again, will just look like that. It's just a matter of moving it up and down and left and right based on what the numbers are in the denominator and what the numbers are on the outside of the denominator. All right, and that should do us for today.